So in this session, we are going to talk about scaling your microservices with gRPC, containers, Kubernetes, etc. Right? So we'll start talking about what's gRPC and like why gRPC should be something that you should consider in order to build microservices. Because microservices, you guys know, is kind of like the new buzzword in the tech, right? We are kind of very much indulged into the phase where everything that we want to build is kind of somewhere somewhat related to microservices. We are gone are the days for the monolith, although I still like recently worked somewhere where a lot of monolith code was there, but okay. We'll be talking about those things. We'll be talking how exactly Kubernetes come into the picture. A lot of things we are going to discuss. So without any further delay, let's just start. So who am I? Why I'm here? I'm Sanket Singh. I'm a software engineer at Google. At Google, I work with Google Pay. I'm not sure how many of you guys have used it, but I work with the client team for Google Pay. Previously worked with Google Cloud as well. I previously worked with LinkedIn, again as a software engineer in the enterprise provisioning team. Apart from the regular software engineering work that we get and the Jira tickets we have to solve, I spent some time in also training and teaching students online around foundations of computer science, DBMS, data structures, a bit of dev, etc. Kind of like a big superhero fan. A bit of Marvel and DC stuff is going to be there in the presentation. So just to make things a bit lighthearted. Right, so if you get the references, give a thumbs up. Okay, so what to expect from the session, right? What and why about gRPC, why it actually came into the picture, why we are talking now about things around RPC. Comparisons and comparisons with other conventions, so comparison with REST and everything, right? We'll be also talking about how you can set up a basic gRPC server and client in Python, right? Although it supports multiple languages, but we can see a bit of Python, and how exactly containers and Kubernetes come into the picture, and how exactly you can use this in order to scale your microservices. Okay. So before we move forward to gRPC, let's get based on the favorite that we have, REST, right? So REST is more or less like a convention for us. It defines a lot of things, a lot of applications that you guys might have already built or might be building, or maybe you have used, may have exposed some of the REST API endpoints, right? So REST is something that we already use. It's widely accepted, widely used. I believe that most of the organizations nowadays definitely have some part somewhere dedicated towards which is using REST. And in the microservices world, we use these APIs in order to communicate, right? The REST APIs in order to communicate. It's kind of flexible. It doesn't put a lot of restriction for you as a developer, right? It's easy to use, like writing a basic REST API in something like Node or Python is going to be a 5-minute thing for us, right? Even less than that sometimes. So it's easy to use. It's kind of like widely accepted, right? It's compatible with browsers, like whatever browsers we are using currently nowadays. It's compatible with it, right? A lot of things also comes along with the REST conventions, like we have predefined set of codes, the status codes that we have defined in order to see what is the current status of the, I would say, service that we are having, right? The API that we have written. Along with that, there are dedicated frameworks. I'm not sure how many of you guys have used it, but definitely you must have heard about it, like Django, Rails, which are like dedicatedly working around REST, right? Most of the scaffoldings and everything work with REST, and they are like power packed with all the support REST from out of the box. So REST is something that is already there, like it was already there for quite some time. And here comes gRPC. So you must have already heard about RPC, remote procedure calls, right? So it's an open source system developed by Google. gRPC is an open source system developed by Google in 2015. Now, if you think the G in the gRPC is Google, that's not the case. It's nowhere written, but we'll assume. Maybe, okay? So Google doesn't tell everything, right? So they are not even telling the full form, but it was developed by Google in 2015, so quite recent. It uses HTTP 2.0, one of the most important features that gRPC comes out of the box that definitely enhances the overall, I would say, performance of your APIs. It uses something called as protocol buffers. We also call them as Protobuf, protobuffers, whatever you want to say. It is again one of the most highlighted features that gRPC provides. We are going to talk about protocol buffers. We will try to write one as well. Apart from that, gRPC is fast, it's secure, it contains features like automatic load balancing and much more, right? So it has a lot of things to offer, right? And it makes sense for us, like we are in 2022, and it makes sense for us to understand that, okay, apart from REST, again, comparing REST directly to something like gRPC won't be a very valid comparison. REST is just a convention, right? But when I say REST, then I mean your regular JSON APIs. When you consume JSON, you return JSON, everything. That we are actually, I would say, referring when I compare REST with gRPC, because gRPC is not just convention. It's a full end-to-end technology that you can use in order to write services, and again, it's going to be super fast. But why now? Like, we are kinda comfortable with REST, right? We have frameworks, we are consuming the APIs, things are going fine, right? There is already a straight way in which we can build our applications. Why do we want to add something spicy to it? Let's see. So if something is already going good, doesn't mean that it is not having any kind of problems. To be very honest, saying that there are some problems with REST is kind of like an opinionated thing. I'm saying problems with REST, it's kind of like an opinion, right? You might not find these as a problem, right? But let's see few of the things that we have. So in JSON, in the earlier days, we had this type checking issues, right? For API changes, you have to do semantic versioning, like you must have either encountered an API or you must have made an API with that /v1, /v2, everything. Like you have to specifically version your APIs every time. Streaming is something that doesn't come out of the box for REST, right? You cannot do bidirectional streaming kind of a thing. There are other solutions like WebSockets and everything, but it doesn't come out of the box. By default, it supports HTTP 1.1. I know that a lot of networking thing we are like discussing. I can't help. I used to work in the networking team only earlier at Google, so just bear with me. We'll be coming to the coding part. But talking about REST's HTTP support, it by default supports HTTP 1.1. You can migrate to the latest version, but it by default gives you this functionality only. You can, of course, migrate it. You have to do manual validations, and one of the most important, I would say, pointer that exists there with REST is the management of the client-side libraries. If you are consuming a REST API with Python, there's a separate library that is maintained by a separate organization. If by Ruby, separate. If by Node.js, separate. Like whatever language or framework you are using, there is a separate dedicated team or separate dedicated community, separate dedicated set of developers who are creating these client-side APIs for these technologies, right? Now just think about it. If in REST, in the later upcoming days, we make some changes, then you can't expect every client-side library to get migrated in single day, right? This is again one of the, I would say, problems that you may think that, okay, we'll deal with it when the time comes, but again, this can be an issue. And we have gRPC to the rescue, right? These problems specifically, gRPC is definitely able to handle. because by default, gRPC gives the support of HTTP 2.0. We're not going to talk very much in depth around how HTTP 2.0 is like faster than the previous version, but in a nutshell, you can understand it gives us new features like multiplexing and everything. So it definitely increases your efficiency. Instead of JSON, like in the REST APIs, or let's say if we go even back, like before the days of REST, SOAP, Simple Object Access Protocol. I'm not sure how many of you guys have even heard about it. Then we used to share XML. I believe everybody must have at least seen some XML. I know it's like old age stuff, XML and like SOAP. I'm not sure if you have heard about it, but yes, these things do exist. And the thing is, we'll be comparing XML and JSON with our protocol buffers. But as per the convention says, and to be very honest, gRPC puts this as a restriction, that you have to use protocol buffers. And we'll see there are definitely some benefits of protocol buffers over JSON and XML. Because of protocol buffers, the API contract that we are going to build is going to be strict, right? And this functionality comes out of the box. You don't have to put anything extra, any other framework, any other service to do it. This strict API contract is going to help us to do all the validation kind of stuff. There are built-in code generators. We'll talk about what I mean by being built-in code generators. But you can say that the problem of different client-side libraries for different languages and frameworks is something that gRPC solves. We'll talk about it. It has services like inbuilt load balancing. And apart from that, for the streaming part, you can do bidirectional streaming as well, directly server to client streaming as well, client to server streaming as well, and your basic unary requests as well. And it is more secure. And of course, we are going to talk about the fact that it's faster than REST, right? It's definitely faster. So if you'll see a lot of, I have linked a few Stack Overflow links in my presentation that you can find in the speaker notes. I don't write speaker notes. I instead put some reference links. But you will find that in the normal production, you will find 7 to 8%, I would say, efficiency increase with gRPC. And that's going to be significantly big if you talk on scale, right? If you talk with the things like the scale at which Google or let's say any social media works, these things are going to be important. So how is it faster? So there is a concept of serialization and deserialization of data into binary format that protocol buffer use. I'll be showing an example in front of you in just a moment. But the thing is, protocol buffer serializes your data, like you are going to send a message, right? In JSON, we always used to send our, like let's say an ID, text, this and that in a complete JSON and send it to the API either to consume or receive it from the API, right? In SOAP, we do the same thing using XML, right? So in protocol buffer, it doesn't directly send your protocol buffer in the communication medium. It first serializes that data into binary format. And our favorite binary can definitely reduce the whole overall size to a very extreme limit. We have already talked about the fact that it uses HTTP 2.0. It can support multiple types of streaming and things like inbuilt load balancing. So this is an example, right? So I've taken this example from one of the Medium articles, again, linked in the speaker notes, right? So for a string medium, right, if you just want to send a string medium, and we have 3 ways to send it. You can send it via JSON, you can send it via XML, you can send it with the protocol buffers. If you send it via JSON, this is how the overall format is, this is how the overall information that will be sent looks like. The above one is XML. It's big, right? It's definitely big. And you can see with protocol buffers that it serializes your data into the binary format. And it is quite small. And this is just for one basic small string like medium. If you have a very big chunk of message JSON that you want to send or receive, this is going to be really helpful, right? So according to the official documentation that Google releases, protocol buffers are Google's language neutral. So first of all, this is language neutral. No matter what technology you are using, this is going to work. Platform neutral, extensible mechanism for serializing structured data. Think XML, but smaller, faster, and simpler, right? You can define how you want your data to be structured once, and then you can use special generated source code easily, write and read your structured data to form a variety of data streams using a variety of languages, right? So Google officially mentions it, that Google is going to handle the generation of the code for all of the languages. We'll see an example with Python as well. So Google took it upon itself, right? As I said, there is a problem, right? The problem of the client-side libraries, that there are different communities who are maintaining the client-side libraries, but that's not the case with gRPC. With gRPC, if you are using gRPC with your microservices, then whatever changes are going to be there, it is going to be shipped, managed, maintained just by Google. Most of the languages that we, at least in 2022, use, Java, Node, C#, Go, Ruby, Python, and there are separate other languages also, for which Google releases the support. The thing is, all you have to do is just prepare your protocol buffers, and the automatic code generator, the compilers that Google releases, you have to just use that, and it will generate the code for you that you can directly consume. You don't have, like, all of this code generation part is abstracted. You don't have to care about it. You just have to care about the logic that you want to write with your service, and that's it. You don't need to care about the fact that whether the client-side library is currently supporting some feature or not. Everything is going to be handled at one point of time by Google. So this is something that I would say the whole load Google took it upon themselves. So we can see a small example, right? And let's see like how this overall code generation thing works, right? Okay, so how much time we have? Okay. So let's do one thing. I guess this screen is not working. Okay, just a second. Okay. So this is like a basic Python, I would say, project. I'm not sure. It's like hardly having 100 lines of code, even less. But it's a small Python service that I've created. And what do we do? Yeah, sure. Okay, cool. So it's a small Python service that I have built, right? And first of all, before we do anything else, let's talk about the proto. This is the protocol buffer, right? So this is the overall syntax that you have to use in order to prepare a protocol buffer. It's going to be a strict contract. It's going to be a strict contract that you have to use, right? For example, we are going to define a message object that is going to be called as to-do item. This is going to have two parameters, an ID that is going to be an integer, and a text that is going to be a string. Now this is something that is going to be now strict from here. You cannot pass anything else in your text or ID, like any other data you can, but we can do that with JSON, right? We can have a key and whatever value we put, we can do that. But that's not the case with protocol buffers, right? if you want to have something which is optional, that you are not going to send every time. For example, like in REST, we have this syntax where if you are going to do something like /API/v1/to-do, and it's a GET request, you get all the to-dos. But if you do /API/v1/to-do/1, and it's a GET request, you get the first to-do, right? So you can define a message object like to-do item, which is having to-do request, which is going to have an optional ID. If you want to send an ID, you can send it. Otherwise, it is going to be optional. So this kind of a syntax is going to work. If you want to send an array of items, you have to specifically mention that it is going to be like for here for array, you have to mention it as repeated, and things are going to work like that. And here you define your RPC. Now in gRPC, again, as I said, gRPC, apart from being a technology, gives you a set of conventions as well, just like REST, right? In REST, the major form of information is what? Your resource. For example, to-do is a resource. You create your APIs, you create the URLs for the APIs based on the resource. What gRPC recommends? gRPC says that you should build these URLs based on action. Like when you have to create to-do, just say /create to-do. When you have to do read to-do, just say /read to-do, right? So you have to be, you have to define your action instead of resource, right? And this is how you define just your RPC. RPC, create to-do, read to-do. It is going to take a to-do item. Create to-do is going to create a, receive a to-do item and return a to-do item as well. For read to-do, you are going to receive a to-do request that is, of course, having an optional ID that we already discussed about, and it is going to return to-do items, that it can return one item. Like it's just a dummy, I would say, Protobuffer. Okay. Now, as I said, this is the basic protocol buffer that we have, right? Now, Google released this compiler for different, I would say, language. Even for Python, there is a dedicated one. So you can just use the gRPC tools.protoc in order to generate some code, as I said, that is going to act as your client-side code, right? So if I show you the exact code what it generates, so here you can see there are two files, todo_pb2.grpc. One is this one, and and this one. Right, so these are the two set of files that this automatic, I would say, compiler kind of a thing is going to do. So if you read this file, if you want to read this file, you will see that it is going to define something called as a stub. It's going to do everything on its own. It's going to define your URL for /create to do. It is going to set everything, like set all the codes and detail, whatever it has to do. It is going to do everything on its own. Like all of this code is going to get generated. You don't have to care what is getting generated. You just have to use it, right? Everything is going to be managed by Google. If there is any change, if there is any nuance that is going to get changed, it will automatically get shipped, right? And then, and the most important part, these kind of compilers is available in all of the languages that supports gRPC, right? Okay. Then all you have to do is just start setting up a server, right? So we are going to start writing the request. I can show you the exact code as well, but we can go here by step. So we'll be defining two functions, create to do, read to do, right? Right. Apart from that, we are going to set up the server. In order to set up the server, all you have to do is just make a just mention that what port you have to use, right? Later we are going to containerize it as well, right? And all you have to do is add to-do servicer to server, right? Like this function is already getting generated from the client-side code that we got. All you have to do is just create the object of the to-do service that we just created here. This to-do service we created, all we have to do is just pass the object and the server context that we have to pass, and we can start the server, right? For the implementation, all you have to do is again consume the same protocol buffer messages, right? So here you can see that we are creating for create to do, we are creating a to do item. For this to do item, we are setting an ID, setting a text, and then we are just returning that reply. I am also maintaining a to dos array just to ensure some kind of I would say persistence. And same thing in read to dos, that you have to just create this to do items. Now the thing is, if we are not going to follow the data types that we have mentioned, if we are going to send anything else instead of the integer or the string that we have defined, it will start throwing error. So it's going to be strict. The contract is going to be strict. Okay. Apart from that, you can also set up your client. So in order to set up the client, all you have to do is set up a channel with the corresponding server's port. You have to create a stub, and you can just start making the call. So here you can see we are making the call of create to do, and create to do expects a to do item as well. So we are going to create a to do item object here with ID1, let's say text is equals to new to do, and we are going to just make a call, and that's it, right? If you have to read to dos, you can just again make a request object with the expectation, and you can just make the call. So I would say in the first impression, this might look like a lot of work to do. You have to prepare a protocol buffer, you have to use the compiler to create all of the code, right? Then you can start writing your server and the client. Yes, of course. In very small scale application, like if you definitely have to make a to do app, this is too much, right? This is going to be very beneficial when you have large scale application, when you have a very big application where a lot of APIs you have written, there are a lot of microservices that you have. In those kind of cases, these kind of implementations where you have strict contract is going to help you a lot. So again, you can just run your Python server, and from the client you can start making the calls, and it will just directly connect. We can definitely see our demonstration as well. But as I said, for the pros and cons, if you will see, gRPC is going to be, if you have just started, right? You are creating your first to do application, then something like gRPC can be a bit overwhelming. REST is simple. I will definitely agree to the fact, and you guys might agree to the same thing as well, that REST is quite simple, right? It's not as complicated, and there are not a lot of steps to get onboarded. It literally takes less than 5 minutes to create a REST API with Python. But with gRPC, you have to do some steps. But if you have a lot of microservices that are interacting, right? And in later, just think about it. In the later stages, if the contracts of one microservice changes, then in the other microservices also, it will be a strict implementation to do, right? So there are benefits, there are pros and cons, both for gRPC as well and for REST. Again, it depends on what business use case we have. It depends on what are our requirements, what is the scale that we are working on. Based on that, we have to make a choice. But this was about gRPC. Like in this talk, I added 2 components. One was gRPC that is going to help you make your services faster. The interaction, the efficiency is going to be increased, right? Apart from that, our favorite containers, right? I'm not sure how many of you guys have used it, but definitely you must have heard about Docker, right? The containers, like there are other technologies available as well. But using containerization, we can definitely scale up and improve our microservices even further. And that leads us to something called as Kubernetes. So again, Kubernetes is something released by Google. So earlier and still till this date, we use something called as Borg, right? Borg is an internal Google tech, and you can say that Kubernetes is just a sophisticated, cleaner, open source version of Borg, right? What Kubernetes is container orchestrator. If I have to define Kubernetes in 2 words, it's container orchestrator. The same thing Borg is still doing, right? And we are heavily dependent on Borg. But we cannot just release Borg, make it open source, right? Everybody can use it. No. So there are some changes that were done, and that led to the technology Kubernetes, right? I would say that Kubernetes is one of the, I would say, most important things if you are working on scale that exist out there. In the developer community, Kubernetes is also called as K8s, like just remove the K, just remove the S. There are 8 characters in between. We are lazy. We replace the 8 characters with 8, and it K8s. So a lot of time you will find people saying it as K8s. But Kubernetes has got a lot of, I would say, use cases. Being a container orchestrator, Kubernetes can do a lot of things on the go very easily. First of all, like there are some terminologies that we can talk about. So there is something called as pod, right? So the smallest unit that you can build is a pod, right? And it works on the, I'm not sure like what's the better version to say it, but there's like a master node and there are like worker nodes. Let's call it as worker nodes. So what Kubernetes does is it manages everything on the go. If one of the worker nodes goes down, it will automatically turn up one more, right? On the go, if you want that if you feel the need that you want to have more workers, you can scale your deployment by just one command, right? And Kubernetes has got a very significant, I would say, support for most of the platforms, right? Be it if you are developing a server on Linux, Mac, or Windows, right? And definitely the documentations is really very good. So let's just talk about it. So what I have done here is, like in the actual implementation here also, if you will see, I have changed the client code to a basic Flask kind of an application. If you will see client.py, I have like commented out all of this. And I have created this basic Flask API where I can have /create to do and /read to do. It is again consuming all of the gRPC code in the same manner, right? Then all you have to do is containerize your server and the client. For containerization, we can use Docker, right? So this is a basic, I would say, Docker file that we have to create. We have to just mention the environment, right? Inside the container, we have to just copy our requirements.txt that is going to have all the libraries that we have. We'll be copying the server, and we'll be installing all the required dependencies. And we will be again using the same, I would say, code generator in order to create the stubs, and things will be done. Apart from that, you have to create a Docker file, again, similar like to server. You have to create it for the client, right? As the client is a Flask app, so you need to have these environment variables set and running. Then what you can do is you can build your container, and then you can run it. We'll talk about like why exactly containers come into the picture. But you can just set up your Docker container like this. You will find this network microservices flag that I have mentioned. So like first of all, we are setting up our containers. Then we are going to push this container to Kubernetes. So in order for two containers to interact, it's a good way that we set up a networking mechanism. So Docker also ships with that. So we have set up a microservices, like I've just named the channel to be microservices. And then the same thing we have to do for the client as well. It's just that the ports will be different. One port is like separate port for client and separate for server. Apart from that, in the client code, if you will see, I'm using a host as gRPC server. If you see here, right? This is the host that we are using. So it's going to get that from the environment variable for our Docker instance, and things will be done. This will containerize the whole application. Now the thing is, why do we need to containerize? Back, again, like quite a few years back, when cloud systems like GCP, AWS, all of these things were not exactly in place. Bare metals that we say in technical terms were there. You have to manually set up a machine. You have to manually turn up your servers. If you have to scale it up, you have to scale the ability of your machine, or you have to put separate machines. And then came these cloud services came into the picture, AWS, GCP, that made things a bit more virtual, right? You can just go and create a virtual server, and things are done. Now, how exactly containers fit into this? It provides you kind of like a protected environment. Otherwise, you don't know that on one actual cloud machine, which is there in their data center, how many actual servers are working. So maybe two different, I would say, applications are running on the same machine, and they are interacting with each other. Or maybe you just log into one of the EC2 hosts, and you are able to access someone else's files. So that's why containerization comes into the picture. It's a bit, it makes the overall environment more secure. And in order to use Kubernetes, it makes sense to use these containers. Now, for setting up Kubernetes, it's just like one single file that you have to create, a YAML file. It's just a bit of configurations that you have to do, and that's it, right? So in the configurations only, what you can do is you can mention how many replicas of the pods you want to have, 5, 7, 10. And these are going to be changeable on the go. Like you are running already your server, right? It's already having its 5 instances running, and you want to scale up. It can be done, right? So all you have to do initially, in order to set up your Kubernetes, in order to set up the Kubernetes, all you have to do is just prepare a YAML file. In the YAML file, set up the containers for both client and the server, right? So here you can see for the gRPC client as well as the server, both of them I have mentioned. Here I am not pulling the image from Docker Hub or let's say Google Cloud, right? I am pulling the image directly from my local. That's why the image pull policy is never, right? Apart from that, we have to expose what ports these containers are going to use inside Kubernetes. And the previous YAML files that I showed you, these are for setting up your deployment servers. Now, in order to access these deployment servers, you have to create services. Again, just few configurations that you have to do, right? You have to set up the service. You have to expose the ports, right? And here you can see in the client, this is for the server. The client is interacting with the server. We will be interacting with the client. In the client, you can mention this type as cluster IP, node port, or load balancer. And yes, you heard it right. So if you are integrating Kubernetes with, let's say, AWS, Google Cloud Platform, DigitalOcean, whatever like available cloud platforms are there which supports Kubernetes deployment, you can use directly their load balancers. We are not going to use it because, again, depends on what service you are using. It may charge you, but again, if you have to scale up things on the go, having a load balancer makes a lot of sense because it will automatically route the request to the least, like let's say whatever policy you are using, based on that it is going to route the request to the corresponding server. And that's it, and that's it. This is all you have to do in order to set up a Kubernetes, I would say, application. Now, let's see. Okay. So let's try to see that how, when I said that if you have a Kubernetes, I would say instance running, you can scale up or scale down your deployments. That is going to be easy. So because we are doing this deployment on the local, we are not using any dedicated cloud platform that is going to give us the IPs and everything. You can use tools like Minikube. Minikube is something that you can use for both Linux as well as Mac, right? And apart from that, there is a tool called as kubectl. So you can do something like kubectl. I'm not able to exactly see, but kubectl apply -f, and let's say the YAML file that you have written is server.yaml, right? Okay, it says these are created. So it directly created a Kubernetes instance for us. Now what we can do is we can go to the Minikube dashboard. So Minikube is a tool, you can directly install it. We are not going to see the installation and everything, we will just see exactly how you can do it. So let's say if you do Minikube dashboard, okay, 1 second. Okay, it's going to fire up the dashboard for us where we can see if the services are up. So let me show you. It's going to be a local dashboard. If you are using any cloud platform, then you will be having their dedicated dashboards. Okay, and let's see. So let's go to deployments. Okay, now here you can see, because we mentioned that for both like client and server, we want 5 replicas each. So these 5 replicas are working. So if you will open, you can see all the logs and dedicated, I would say, action items for them. Now let's say that you want to scale up, right? You want to scale up your deployment to, let's say, 10, right? Just a second. Yep. So what you can say is kubectl scale deployment, and let's say for the server, instead of 5 replicas, now we want to have 10. All you have to do is just pass a flag ---- replicas equals to 10, and it says the server scaled. Now if you go here, you can see from 5 dedicated instances, now you have 10. It's that easy, right? It's that easy to just scale up at any point of time, right? So that's where Kubernetes come into the picture, that if you have a lot of microservices and if at any point of time, any one of the service you want to scale up, scale down, if you want to have very high availability. So a lot of times we have dedicated services which is expected to have extremely high availability, then Kubernetes is something that we can directly use. If any of the nodes goes down, it is going to turn up at the same moment of time one more replica for it, right? So Kubernetes is going to help us with that. And if let's say if you want to test your Kubernetes, that is like we have not deployed it on any cloud platform. If you want to just test your Kubernetes on your local, you can set up something called as ingress, right? That comes as a by default support for Kubernetes, and you will be able to make a call directly through ingress. So at last, I would like to say that if we have when I was working with LinkedIn, the whole architecture was exactly set up with microservices. So if you have a huge bunch of microservices that are interacting with each other, then you can use both gRPC and Kubernetes as 2 separate fronts which will help you to scale up your services. Using gRPC, not only you get efficiency, not only you get better reliability and security, but you get contracts which are going to be strict. With Kubernetes and containerizations, all you have to do is just see what is the expectation, and whenever you want to scale it up, you can scale up your services, you can manage inter-service communications. Containerization automatically is going to be there because it's the requirement for setting up Kubernetes and whatnot. So on and on, I would say gRPC is something definitely worth a try. If you are building something very small, I at least never use something like I would have never used something like gRPC for something very small. But I would say that if there is like very complex communication that you have to do, gRPC makes a lot of sense. Cool. So I guess we have some time, so we can definitely take up some questions if you have.
gRPC is mainly defining like a object contract and
Okay, so as I said, apart like of course you can do the load balancing part manually also. Like gRPC comes with its inbuilt capability for load balancing. So let me show you. So if you see this client side load balancing, this is a very good article from Microsoft. I'm not sure why for understanding gRPC we have a Microsoft article, but you can see that for the client side load balancing, the client that you have set up, gRPC comes with its inbuilt capability of doing the load balancing, right? You can have separate strategies, like whatever strategy you want to have for the load balancing part, you can do that. All the DNS resolution and everything is going to be done, right? So if you go here for the strategy part, it defines two strategies, the pick first and the round robin, and all you have to do is just configure your load balancing there, and whatever servers you will be having, it will automatically reroute your requests, because you have set up a dedicated channel in order to connect the client to the server. Now it's gRPC which will be deciding, if let's say you set it up, it will be gRPC which will be deciding what server to hit. So you can definitely use that. Like I've already added this article in the speaker notes, so you can also read about it.
I just wanted to ask about gRPC and browsers. Obviously, gRPC web exists, but is there any progress update, I guess, on gRPC using HTTP2 in browser, or do we still only have gRPC web?
I'm not sure about the browser part, but yes, there is some support that has been released with the browser. I myself have never worked with gRPC on browser, but in the initial days, it was definitely a hiccup with the browsers. But yes, there exists some support, so I might have to look at it. But I have not first-handedly used gRPC with browser, so yeah, we have to check it up.
I like the idea of protocol buffers being contracts, but can you imagine it being used by multiple clients across different code bases, using different languages each? Is there any best practices around sharing protocol buffers in those scenarios?
Sharing protocol, like again, you can define your protocol buffer in a similar manner that you define a contract, right? And the client side, as I said, the client side library that Google provides is going to automatically generate the code for everyone. Let's say you have 3 services that are consuming, sending the same protocol buffer, like either consuming or sending. Now all you have to do is use the same protocol buffer signature, right? A common protocol buffer signature is going to get used, and whatever client side, like you can set it up separately, and whatever client side library you are using, let's say a Ruby service, Node service, Python service, you can use the Python's compiler and the code generator that to generate the same protocol buffer code for Python or Node service, and same for Ruby service. Now if you are using the same generated code, then it is automatically going to ensure the fact that you are handling the contract in the same manner in all the 3 services. So it's going to be common there. Yep, anyone?
Since gRPC uses binary payloads, right? So one of the advantages of using REST is that it's easy to troubleshoot because you can actually see and read, what's being transmitted over the network. Is there any tools or any, something that would allow us to see what's happening without actually taking, the binary and transforming that into something?
Okay. So I'm assuming that whenever we do any kind of debugging, logging, anything, we do on the service end, right? The thing about sending a binary is when you are going to send the message, then over the network, you are sending a binary. So it's like a small payload, right? it does the serialization and deserialization part on the end service. So when you're going to get the message, it will it's not like you are sending the message, it serializes it, and the other service is going to consume the serialized message. No, it is going to deserialize it. So for the debugging and logging part, there won't be an issue. It's just that when you are sending the message on the network, the overall data packet that you are sending is now small, right? So the same amount of information is getting sent with a smaller packet. That leads to a faster transmission of the overall data. So for the debugging and logging purpose, because you do it on the end service, right? You we just don't go to the network layer and then see, okay, well, where's our packet? That's the same thing here. We are just going to debug on the end service, and things should be fine. And for debugging, whatever technology you're using, Python, Ruby, there are dedicated debugging tools we can use. Okay, so let me give you an example. So let's say that we have a node service. Let's say we have two services. So one service is exposing an API, and one service is consuming an API. So while consuming an API, while exposing an API, let's say the API expected you to send an integer, right, for some, let's say, cost. When you are sending a request from the other side, you didn't send an integer, you send a string. So how you are going to check? You have to do manual validation, right? That's not the case with gRPC. The moment the other service is going to violate the protocol buffer, that's a strict contract. It's going to throw an error on their end only. That, hey, I didn't expect a string. Please send a text. That's the part. You don't have to do manual validation, right? I still remember writing my first Express application and dedicatedly writing separate middlewares for validations. But that kind of hustle, that kind of, again, that extra code that we will be writing is kind of getting saved here, right? So I guess that answers the question. Yes?
If I want to make sure that only authenticated users access my gRPC service, what's the best way of doing that?
So if your authenticated users only are trying to access, so how about you, what's the problem with a regular authentication service? I'm not, we just want an authenticated user only to access our API, right? That's
Number one, in your talk, you didn't talk specifically about securing the layer, the transport layer.
Yeah.
You didn't talk about securing the actual package of data either. So my question really is about the nature of security in gRPC. It's great that gRPC is so awesome. However, if it means that everyone can have access to it when I don't want them to, how do you secure it?
Okay, so first thing is securing on the transport layer, the message part, because we are serializing and deserializing the data. Okay, I'm not sure if I mentioned that in the talk or the question, but the serialization and deserialization of the data happens on the end client. It doesn't like any other intruder cannot just parse or read the message in between. So you will be getting a binary, right? You're not going to get our raw data. First thing of a secure communication comes directly here. So that's first level of security. Apart from that, you can have manual, in just the same manner, your regular REST APIs have their dedicated validation and authentication. You can do the same setup here as well. So the serialization part happens on the end machine. It's not like we can intercept the communication in between. We'll be getting a binary. We won't be able to see, okay, what's inside that. Okay, so like for dedicated, yeah, that makes sense that we have a bearer token strategy that we can directly send over the headers. For gRPC, that like dedicated headers doesn't exist, but yes, you can use a separate, I would say, a separate service you can definitely create for your authentication and authorization, right? I'm not sure about any headers that we can send with gRPC. We have to maybe look at it, but yes, like a dedicated authentication service you can definitely build on gRPC. Yep, sure. Uh,
So if gRPC is sending primary between client and the receiver, what if it's stuck in between? For example, if you're sending to a message queue and then it's stuck there, you have to look into the content of the real message, but we are actually sending primary here. You can't really easier like how.
Okay, so let me understand the question. So from the client to the server, if let's say if at any point of time we are not able to complete the communication, right?
Yeah, let's say it's stuck in message queue and it's not being picking up correctly.
We can have retry mechanisms there in the same way that we have like if it's reaching our message queue, if it's at the message queue, then we can have manual workarounds like the retry part. If let's say in the layer, because in the transport layer, we have this TCP, like in the TCP protocol, we have this sense of, I would say, security about the fact that a packet that we are going to send, it's going to be like a reliable way of communication, right? So for that part, we are again going to use the same transport layer. But for if let's say if we are able to receive the message on our message queue, like it's a queue that's we have set up in between the two servers, we can have dedicated retry mechanism set up in place. Yep, sure, sir. Like, yes.
You mentioned versioning issues earlier at the start. How do we avoid those versioning issues when we change the protocols?
Okay, so the same like again, first of all, like versioning, as I said, issue might not be an issue for everyone. First thing. Second thing, using protocol buffers, as I said, whenever we are going to change the protobuf, all we have to do is just do the regeneration of the code using the compilers. It is going to handle everything. You don't have to set up a separate like set of routes to expose the, I would say, new set of contracts. If you have a new protocol buffer set up in place, all you have to do is just do the recompilation of the code. Everything is going to get generated for you. That's how we are going to avoid separate dedicated versioning that we have to. Now, let me answer. Now let's say, now you consider a case when let's say one of our service is not consuming the updated protobuf, right? So there can be a case that let's say we updated the protobuf, most of the services are consuming, but still there are a dedicated, like still there is a service that is not consuming the updated protobufs. In those kind of cases, we have to do some manual checks, right? We have to make sure that our previous protobuf is getting supported, but you don't have to reroute everything or like write new routes. Like for API versioning that we do, we have a separate set of routes, /v1, then /v2, then /v3. We don't have to do that. All we can do is the same RPC, the previous RPC is also getting supported by few of the servers that other services that are still not migrated can use, and then later with time we can do that. Or you can have a stricter implementation that no matter what, if this like the updated protobuf you are not going to use, we are not going to support it. So again, whatever kind of like migration we want to have, we can do that. Cool. So thank you for your time. You guys were a fantastic audience.